let's do this question. You are given an array of integers in which each subsequent value is not less than the previous value. Write a function that takes this array as an input and returns a new array with the squares of each number sorted in ascending order. Now let's try to understand this question. We will be given an array of integers and each subsequent value is not less than the previous value. That means every subsequent value can be either equal or greater. So basically we are given an array of integers that's sorted in ascending order, and the output of the function should be an array where the squares of each number is sorted in ascending order is what's contained in the new array. So this is the question. Now when you're given such a question in the interview, always feel free to ask clarifying questions. So this is very important so that you and the interviewer are on the same page, that you are very clear with the expected output. Now a possible question that you could ask is, are all numbers positive? Over here it's mentioned an array of integers, right? Now at this point, let's say that the interviewer replies, no, there can be negative numbers and there can be 0 also as an integer. Alright. Now another question could be, are all the integers distinct? Now a possible answer can be not necessarily, so that's not required. And another question could be, can an empty array of integers be given as an input? Now let's say the interviewer replies and says, yes, that can be possible. In that case, return an empty array as the output of the function. Alright, so now we have understood the question and we have also asked clarifying questions, and the interviewer and the person who is giving the interview are on the same page. You have clarity on what the question asks and what the expected output is, especially in the case of edge cases. Alright, so as a next step, to understand further and to formulate a logic in our mind, it's always helpful to write down different test cases. So test cases are different inputs and what the expected output is in all those particular cases. And when you're forming test cases, you can work with the interviewer. You can ask the interviewer, is it okay if we come up together with a few test cases based on the criteria that we have discussed? So you can always do that, and that's helpful. Now let's form a few test cases for the question at hand. Let's say the input is an array where 1, 3 and 5 are the integers in the array. Now we would have to square these and sort them, right? So 1 square is 1, 3 square is 9 and 5 square is 25. So the output should be 1, 9 and 25. Now let's say we have another array which is 0, 5 and 6. So what should be the output in this case? In this case the output should be 0, 25 and 36, right? 25 is 5 square and 36 is 6 square. Now over here, in these two cases, an interesting thing is that the position of the square has not changed, right? So this is the first, and again 1 square is also at the first in the output array. And you have 3 at index, let's say 0, 1, 2, and these are the indices 0, 1, 2. So at index 1 you have 3, and at index 1 itself you have 3 square, which is 9. And at index 2 we have 5, and at index 2 we have 5 square, which is 25. So in these two cases this can be observed. But let's say we have an array with negative and positive integers like -4, -2, 0, 1, 3. Now what's happening over here? First, let's square these individual integers. So -4 square is 16, -2 square is 4, 0 square is 0, 1 square is 1 and 3 square is 9, right? Now in the output, these have to be sorted, right? So the output would be 0, 1, 4, 9 and 16. Now we can see that the position has changed. This is 0, 1, 2, 3 and 4 indices, and over here let's look at the indices. We can see that here -4 was at index 0, but -4 square, which is 16, is at index 4 over here. So this also has to be taken care by the algorithm. And again, if we have same values, like for example we have 2 and 3, 3, so the output would be 4, 9, 9. So that's also possible as per the questions that we have discussed with the interviewer. Hi everyone, I hope you have thought about how to solve this on your own. Now let's look at how to solve this together. The first method is the brute force method. Alright, so let's look at this method over here. For this, let's take a sample input. Let's say the input is -3, 1, 2 and 7. So we have this array as input. Notice that this is sorted. Alright, now the brute force method is that we just square each element and put it in a new array, right? So that after doing that, what would be the array? The array would be 9, 1, 4 and 49, right? We are just squaring each element and putting it in a new array. So minus 3 square is 9, 1 square is 1, 2 square is 4 and 7 square is 49. Now notice that this array over here is not sorted now. So the next step would be that we have to sort this array. And once we sort this array, we will get the required output, which is 1, 4, 9 and 49. Now this is very simple, but it does not have the best space and time complexity. Now let's look at the space and time complexity of this solution. Now over here, notice that we have traversed the array and we have squared each element and put it in a new array, right? So we have traversed it one time. Let's say this array has n elements. So the time complexity of this operation is O of n, right? We're just traversing it one time. Now after this, we have to sort, right? We have to sort the given array to get from here to here, right? Now any good sort is has a time complexity of O of n log n. For example, quick sort, etc. Right? So the total time complexity of this algorithm therefore is equal to O of n log n. Now you could say that it is O of n log n plus n, right? O of n log n plus n. Yes, we can say that, but again this simplifies to n log n. Why is that so? Because n log n is greater than n, right? In the logarithm section we have seen that already n log n is greater than n. Now if n log n is greater than n, you can either just remove this and you're just left with n log n, or you can think of it in this way. Instead of n, let's replace it with n log n. So when we add these two, we get 2 n log n, and then this is a constant, so we can remove the constant, and again we are getting n log n. So the time complexity of the brute force method is n log n. Now what about the space complexity of this solution? Over here, notice that we have made a new array with n elements. So we have consumed some space. Therefore, the space complexity of this algorithm is O of n, right? This will have n elements. If the input array has n elements, the new array also will have n elements. So the space complexity is O of n. Alright, so we have seen that the time complexity is O of n log n and the space complexity is O of n. Now, this is a brute force method. We will see in the next video how we can do better than this. Let's now get into the code for the approach that we have discussed in the previous video. So first we are going to create a new array. So let me write let new array. So let's just call it new array itself. And this new array will have the same size as the input array which is given to us over here. Okay. So let new array equal to new array, and the length of this is going to be array.length, where array is the input array which is given to us over here. Okay. And what we are going to do is over here, we are going to fill the value 0 at every index in this new array. So I can say dot fill 0. Okay. So at this point, new array has the same size as the input array, but every cell in the new array has the value 0. Now what we're going to do is we're going to iterate through every index in the new array, and then let's go ahead and square the element in the input array and place it at that particular index. So I can say for let I is equal to 0, I less than array.length, I plus plus, okay, and over here I'm going to say new array at index I is equal to array at index I into array at index I. Okay, so that's it. So we have filled the new array with values such that at every index we're just squaring the value in the given input array and placing it in the new array. But we have seen that this will not work, because if the input array has negative and positive numbers, like for example, if the input array is something like -4 and then you have 1, 2 and 3. Okay, so clearly -4 square is greater than 1 square, so this will not work. So what we have to do is after this, okay, so let's have 3 over here. So after this we have to go ahead and sort the new array. So let's do that. So I can say new array dot sort, and we're going to sort the array in ascending order. So I can say a comma b, and the criteria is a minus b. So we are sorting the new array in ascending order. And finally, we just need to return the new array. So I can say return new array. Okay, so this should work. Now let's go ahead and run this code and see if it's passing all the test cases. And you can see that it's passing all the test cases. Now you can make use of the user logs. Okay, so in case you're stuck somewhere, do make use of it to debug your code. So you can just add console log statements and you can print what is happening at that particular stage of your code, and that will help you debug your code. But over here, you can see what is the input for various test cases and what's the expected output and what is the actual output. In the previous video, we saw how we could solve this problem with the time complexity of O of n log n and space complexity of O of n. Now anyway, we have to form a new array, so we cannot improve on the space complexity, but let's try to improve the time complexity, which is O of n log n as per the brute force method. Now notice that in the previous method, we did not use the fact that the input array was sorted, right? Now let's try to make use of that fact and improve the time complexity. Alright, so we're going to try to use of the fact that the given array is sorted in ascending order. So let's look at it now. Now again, we have an example -3, 1, 2 and 7. Now first let's make a new array and initialize all of the indices of the new array to 0 and let the length of the new array be the same as the length of the initially given array. Alright, so we have done that now. Now let's look at a property of numbers. Over here we have the number line, and notice that as you go towards the left and the right from 0, the value of squares keeps increasing, right? For example, let's say that you have 1 over here, you have 2 over here, and you have 10 over here. So as we go from 0 towards the right, the square is 1, 400, etc. So it's increasing. And the same is observed when you go towards the left also, right? So you have -1, let's say you have -3, and let's say you have -9. So as you see, as you go to the extremes, the square value increases, right? So the same has to be true when we look at the sorted array which is given to us, right? Now we are more likely to find the greater value as we go to the two extremes of the given array. Now why do I say that we are more likely? It could be that our array is just 1, 2, 5 and 10. This also is a sorted array. Now over here you can see that we are only part of this part of the number line. So as we go towards the right, the squares increase, right? But then we could also have an array which is like -9, -8, 1 and 2, right? So over here we can see that we have moved more towards the left from 0 in this part. So the square would be higher here rather than here. So this is an interesting property. So let's try to make use of this property to solve this in a better manner. Now, because this is true, if we look at the two extreme positions of the given array, which is this position and this position, and if we square them, then one among these two definitely has to be the greatest, right? The greatest square. Now, why is that so? Now, if we have a value over here and let's say we have a negative, I have -3 and I have -2. So definitely -3 square will be greater than -2 square. So yes, this is true. And again over here also, if I have 2 and 3, 3 square is greater than 2. So we are just looking at which is the greatest positive value or the greatest negative value, right? So we just need to look at these two extremes and we can be sure that one among these two will be the greatest when we square it, right? So let's make use of this property to solve this question in a more time efficient manner, right? So one among these two has to be the largest. When we square all these four, the largest has to be one among the squares of these two, right? It will definitely not be one among the squares of these two, right? All right. So let's look at that. 3 square is 9 and 7 square is 49. So 9 is less than 49 or the greater value is 49. So let's take this 49 and we fill this 49 over here. That is the new array. This is the new array which we made, and let's fill this 49 at the last position of the new array, which is over here. So we write 49 over here. Now we got this 49 by doing 7 square, right? So we have already used this up. So let's move the pointer from here 1 to the left, which is to 2. All right. So again, our pointer, one pointer is over here and one pointer is over here. Now, the next greatest or the next largest when we square these three has to be one among the squares of these two, right? So let's look at that. Minus 3 square gives us 9 and 2 square gives us 4. Now 9 is greater than 4. So let's fill the next position in the new array, which is this one over here. Let's fill the new position with 9. So we put 9 over here and we got 9 by squaring minus 3. So we have already used it up, and hence let's move this pointer 1 towards the right? So we move the pointer over here. Now the two pointers are at 1 and 2. Now again, the next largest has to be one among the squares of these two. So again, when we square, we get 1 and 4. 1 is less than 4. So we fill 4 over here, which is at the next position in the array, the new array which we are creating. And we are just left with 1. And the two pointers at this point at the same value, and we fill that over here, which is 1, right? Now we can see that we have got the array and it is sorted. We got 1, 4, 9, 49. So this is the array and it consists of the sorted integers of the given array, and this array over here is also sorted. So this is the better optimized solution or the better approach by which we can solve this problem. Again, remember the property which we used is that the greatest, or when we square all the input, like let's say we have an input array like minus 10, minus 3, 5, 9, 11, 12. So even irrespective of what the values are given in the array, the greatest when we square all of these will be one among minus 10 square and 12 square, right? So we just need to compare these two, find the greatest and fill it at the last position of the new array, and then whichever was used up, shift the pointer accordingly and keep comparing those two values and find the next one. In this way, we filled the largest value at the rightmost position, the second largest value at the next position, and we kept repeating that, and we got the sorted array where each element was the square of the given elements in the initial array. Alright, now let's look at the space and time complexity of this approach. Initial approach, we have seen as per the brute force solution, the time complexity was n log n and the space complexity was O of n, right? Now let's look at the space and time complexity of this solution. Over here, we can see that we are only traversing the array once, right? So the time complexity is only O of n. Now this is because we are just moving or traversing the array one time, right? Now what about the space complexity? The space complexity is still O of n because we are making a new array, which is this array over here. Now we can see that by using this property and the fact that the input array was already sorted, we were able to optimize the solution, and instead of O of n log n, we got a solution with the time complexity of O of n.
Let's now get into the code for the second approach that we have discussed for solving the sorted squared array question. Okay, so we're going to start by creating a new array. So let me say const new array is equal to new array, and this new array will have the same size as the input array, which is what is given us over here. Okay, so over here I'll say array.length, and what we're going to do is we're going to fill every cell in the new array with the value 0. So over here I'll say dot fill 0. Okay, now we have seen that the highest value will either be the squared of the leftmost element or the rightmost element in the array which is given to us. So let's have two pointers. So I'll say let pointer left is equal to 0, which is the leftmost index, and also I'll say let pointer right is equal to array.length minus 1. Okay, now I'm going to iterate over every index in the new array which we have created over here, but we will start at the last index and go up to 0. So over here I'll say for let I is equal to array.length minus 1 and I greater than equal to 0, because we will be going till I equal to 0, and I minus minus. Okay, now we'll find the squared value of the leftmost element and the rightmost element. So I'll say const left squared is equal to math.pow array at pointer left, okay, and we are squaring it, so comma 2 over here, and similarly const right squared is equal to math.pow array at pointer right, and again comma 2, okay, because we're squaring it. Now we're going to compare these two values. So I'll say if left squared greater than right squared, so if this is the case, then we will say new array at index I is equal to left squared, and because we have used up the left squared or the element at which the left pointer is pointing at the current moment, we are going to change that pointer by incrementing it. So I'll say pointer left plus plus. Okay. Now if this is not the case, what we are going to do is we'll say new array at index I is equal to right squared, okay, and then because we have used the element at which the right pointer was pointing, we are going to shift the right pointer by decrementing it. So I'll say pointer right minus minus. Okay, so that's it. So this should solve the question. Now all that remains is we'll have to return the new array. So over here we'll say return new array, and that's it. Now let's go ahead and run this code and see if it's passing all the test cases. And you can see that it's passing all the test cases. And again, do make use of the user logs. So for every test case, you can see the input, the expected output, and the actual output when you take a look at the user logs for each individual test case.